Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So now we move on to the Orthocenter property supplementary. Here, in a triangle, the line passing through the projection points from orthocenter to the angle bisectors of each angle's interior and exterior angle are concurrent. The concurrent point is the center of 9-point circle. Let's try to prove this. So basically it's saying that in a triangle, the line passing through the projection points from orthocenter to the angle bisectors. So we find the orthocenter first, and then we find the angle bisector. For example, here in triangle ABC, we find the interior angle bisector AI and exterior angle bisector, this line. Then we find the projection from orthocenter to these two lines, which is L for the interior angle and J for the exterior angle. Okay, so we know that this is 90 degrees and this is 90 degrees. And we want to prove that the line passing through these 2 points in this triangle are concurrent for each vertex, right? Here we just find the projection points from orthocenter to the vertex A interior and exterior angle bisector. And for the B and C, we do the same thing. And we want to prove that this line is passing. We want to prove that this line and another line here and another line here, these 3 lines are concurrent. And we want to prove that the concurrent point is the center of the 9-point circle, which is the midpoint of the circumcenter and orthocenter. So if we just change our mind to do this proof, basically we just need to prove that J, I, V are concurrent. Or let's say it this way. The line JI meets OH on a point V. We just need to prove that V is the midpoint of OH. Right? Because the midpoint of OH is the center of 9-point circle. And we prove that this line passing through V, other lines, similar lines, they also passing through this point V. Right, because we can just use the exact same proof method. Okay, so let's look at how can we prove that IJ is passing through the midpoint of OH. The first thing we can think of is that how can we prove that JI is a line that passing through a midpoint of another line. So we need to understand what is I and what is J. I is a projection from orthocenter to the interior angle of the angle bisector of angle BAC, right? Which means the angle IAH, we can calculate for it, right? The angle IAH, we want to calculate for this angle. The angle IAC is half of angle A. And the angle HAC is 90 degrees minus angle C. So we can use this one, minus 90 degrees minus angle C, which means A equals to half of angle A plus angle C minus 90 degrees. right? And the question is that now we get this angle, it's half A minus this angle, and this one is 90 degree minus angle C, so we got this one. What about this angle? The angle OAI. The angle OAI equals to the angle BAI, which is half of angle A minus the angle OAB. The angle OAB equals to, because the angle BOA is twice of angle C. So if we find the perpendicular bisector of the segment AB, we know that this angle, the angle AO to here, this angle is angle C, which means the angle BAO is 90 degree minus angle C, right? So it equals to this angle, the angle OAI equals to half of angle A minus 90 degree minus angle C. Of course, we know that angle IAH equals to angle OAI. This angle equals to this one. Now it's interesting because we know that AI is perpendicular to IH. And we know that AI is an angle bisector of angle BAC. And AI is an angle bisector of OAH now. Which means if we mark this point as X, we mark this point as Z, we mark this point as Y, then we know that ZI equals to YI, right? ZI equals to YI. And also XI equals to HI. So XI equal, I think I gave the same name for this point and this point. Right here, I call it I. This point, let's call it N. Yeah, okay. So all other things are still maintained, right? So it's just XI equals to HI, and ZI equals to YI. This tells us one thing, that I is a midpoint of, or actually I make this as L. Anyway, let's call it I now. Okay, let's call it I now because I always use this as I. So now I is a midpoint of XH. Right, remember what we want to do is that we want to prove IJ passing through the midpoint of OH, which means we just need to prove that because if V is a midpoint of OH, we know IV is in parallel with XO, which means that if we want to prove that IJ is passing through the midpoint of OH, we just need to prove that IJ is in parallel with AO. And we already know that AI is in parallel with JH, right? Because AIHJ is a rectangular. We know that AI is in parallel with JH. So we just need to prove that this angle equals to this one. Then we prove that IJ is in parallel with AO. So the question is what's this angle? Oh, because AIHJ is a rectangular, we know this angle equals to this one, right? The angle IJH equals to angle IAH equals to angle IAX. So this angle equals to this one, and this line is in parallel with this line. So this line is in parallel with this line, right? The line so we get ij is in parallel with ax, which means ij is iv. And we know that ij is passing through the midpoint of OH. And of course, for other vertex, if we do the similar projection connection, we know it's also passing the midpoint of OH. And it's a center of the 9-point circle. We already learned that. Okay, so conclusion. In a triangle, the midpoints of each side, the midpoints from orthocenter to vertices, the projection points from orthocenter to the interior angle bisector and exterior angle bisectors, the center of 9-point circle. These 5 points are collinear, and we have three groups of that. So basically, we want to prove that we already proved J, I, V are collinear. And now we want to prove that this point, the midpoint of AH, is also on JIV, line JIV. It's obvious, right? Because the midpoint of because AIHJ is a rectangular, the midpoint of AH is the intersection point of IJ to AH, which means that the midpoint of AH is also on the line IJ. Another question is that whether this line passing through the midpoint of BC or not. So just think about that. If we already have this point as a midpoint, think about the midpoint property here. We know that in the 9-point circle, the center is on the V, and we know that 9-point circle passing through the midpoint of BC, let's call it N, passing through the midpoint of BC and passing through the projection or the foot of the altitude D, right? It passing through this point, it passing through this point, and also it passing through the midpoint from the orthocenter to the vertex, which means that these 3 points are on the 9-point circle, and we know that angle ND to this point as let's call it T. The angle NDT is 90 degrees. That means, see, NDT are on the 9-point circle and angle NDT equals to 90 degrees. That means NT is a diameter, right? NT is a diameter of the circle V, which means the TV line is passing through N, right? Because NT is a diameter, and we know that V is a center. So that means the TV line is passing through N. And we already know that V, I, T, J are collinear, and it's passing through N. So we know that these 5 points are collinear. And we have 3 sets of that because we have 3 sides, right? So conclusion 2. In a triangle, the midpoint of each side to the midpoint from orthocenter to the opposite vertex are concurrent. So the midpoint of each side, which from here is N, to the midpoint of orthocenter to vertex, that's T. So it's NT, right? And we have 3 sides from 3 sides. These 3 side lines are concurrent. That is obvious because they are passing through the point V, the center of the 9-point circle. Okay, so this is a property, basically just to demonstrate some collinear and concurrent lines. I hope you like this video. See you in next one. Thank you.